In this lesson, we're going to be writing electron configurations, and we're going to be doing the two different techniques called longhand and shorthand configurations. So electron configurations are using the orbital diagrams from the last video, and they're very good methods of understanding what quantum mechanics is. So an electron configuration is basically the mailing address of an element that is found on the periodic table. So instead of saying the actual element name, you can rally off a code, and that code represents the actual element in its very, very, very specific location on the periodic table. So again, when you read the periodic table, you are always reading from left to right. And when you get to the end on the right-hand side, you go down a row, and you restart on the left-hand side. Very much like reading a sentence, or a paragraph, or a book.
So remember we were talking about Pauli, Aufbau, and Hund's rules in the last video. They all correlate with this orbital diagram that we discussed. And from there, we can create these long notations and short notations. And in a later video, we'll also discuss these quantum notations. So an orbital diagram like this one above, where you see 1s, 2s, 2p, 3s, and 3p all being occupied by electrons, some fully and some not. But we're going to use this to create a longhand electron configuration. So the rules are, write the lowest energy level first. So you're going to write 1s, 2s, 2p, 3s, 3p. Then count the number of arrows in each of those sublevels individually. So you'll notice that in the 1s we have 2 electrons, the 2s we have 2 as well. The 2p we have 6 electrons, the 3s we have 2, and finally the 3p we have 4. So we're going to write those numbers down as exponents after the sublevel itself. So you'll get 1s2, 2s2, 2p6, 3s2, 3p4. And then from there, if you count up all those exponents, it comes up with the total number of electrons in this element. So there's 16 electrons. Now 16 electrons would represent 16 protons, which means this element has to be sulfur.
If you want to write a shorter version of that giant code, again, just find the elements on the periodic table. Or if you already have the longhand configuration written, you can use that. So find the element on the periodic table, and you count the atomic number backwards until you reach a noble gas. And a noble gas is group 18, which is the far right-hand side. So from a long configuration, you can also find the last p sublevel. So if you notice over here, we have a 2p6, which is full, but a 3p4 is incomplete. So technically, everything from 2p6 to the left is going to be our noble gas configuration. And if you count them up, 2 plus 2 plus 6 is 10, and that would be neon. So you are going to write the noble gas symbol in a bracket. After that, you just add the rest of the code, which is 3s2 and 3p4. If this is confusing, let's try this method. Again, find the element. It's sulfur. Go backwards on the periodic table until you find a noble gas in group 18, which is going to be neon. Start the configuration from the noble gas by writing its name out in a bracket, and then going 3s2 to 3p4. Therefore, sulfur has a shorthand configuration that looks exactly like that.
Both configurations are exactly the same though.